today we are going to solve some previous year questions. So let's see. So this question, today's class will be very brief. Okay. So we will just solve some problems and after that I will give you some other problems also related to the previous year questions and some from previous year's questions itself. So this question is from 2021. So here they have given you one transformation yx is equals to e to the power x bx. Okay, reduce then they want you to reduce the ordinary differential equation. This is the given ordinary differential equation that they want. Just you need to find the dy dx and d2y by dx2 from here using this relation and put it into here and then put it into this form. Okay, then you need to find alpha, beta and gamma, and they want the question is the arithmetic mean of alpha, beta, and gamma. Then what you want to do? What you have to do? Alpha, beta, gamma. When you find, then you just need to find that alpha plus beta plus gamma by 3. That is the arithmetic mean of alpha, beta, gamma. Okay. So let's see how we can proceed. So y is equals to d by x vx. This is the transformation that is given in the question. Just need to differentiate it in first order differentiation. Okay, you know the chain rule, right? So this is easy. Then again, you need to differentiate it. You will get this second order differentiation. Now just put these things d2y by dx2 you put here and dy by dx2 dy by dx you put here in terms of b. If you put and then do the calculation, then what you will get x into d2v by dx2, sorry, and here dx2 will be there. Okay, there one wrong thing. Let me find that. d2v by dx2 x d2v by dx2 plus 2 dv by dx plus 0 vx. Okay, this form. Now you need to compare it to the given form. Okay, what is the given form? Alpha x into d2v by dx2 plus 2 beta dv by dx plus 3 gamma. So by comparing you can simply get alpha is equals 1, beta is equals 1 because 2 beta they have given 2 beta is equals 2, so beta would be 1, and vx there is no vx term, so gamma would be 0. So arithmetic mean of alpha, beta, gamma you can get simply 1 plus 1 plus 0 by 3 is equals to 2 by 3, and the answer is 0.667. Okay, that's it. Next question is from 2020. This question is not you don't need to actually solve the differential equation. You can simply get the solution, get an idea about the nature of b by simply some concept. Okay, here the question is, let zt be the solution of the initial value problem. This is the initial value problem because you know the value of dz by dt at 0, which is the initial value of t. At initial value of t, you know the value of z, and initial value of t, you know the value of z, first differentiation of z, dz dt. Okay, so if the planar curve parameterized by t having x coordinate zt and y coordinate dz by dt is closed, so they have given that the curve is closed. Okay, the planar curve is closed. Then necessarily what it will be the nature of b? Here they have told that b is a non-zero. Okay, this is another option. This option is a. This is a. This is b. This is c. This is d. Four options are there. So what would be the nature of b? So they have stated that the planar curve is closed. So a planar curve, if a planar curve is closed, then there is one condition it must follow is that it has to be a trigonometric function. Okay. So your given equation is this: d2z by dt square is equals to bz. Now you just put dz by dt is equals to d. Okay, then d2z by dt square. Then d2z by dt square would be what? D square. Your this term will become d square and minus b. Okay. So this another step. If I do here what will be like d squared z minus bz. Okay, is equals to 0. Then z you take common and d square minus b is equals 0. So the auxiliary equation would be like what? If you replace simply here, here capital D is what? D by dt. Okay. D square will be what? D square by dt square. Okay. So auxiliary equation you just simply replace d by m. So m square minus b. Now this equation to have, you know that yesterday's from the yesterday's last week's lecture where we have discussed like how to solve the auxiliary equation. If your auxiliary equation is of the form m square, let's say m square is equals to b here in this form. So if let's say your b is positive, then you will get simply two roots plus minus root b. Okay, in that case your function and this complementary function would be what? Complementary function CFY would be what? E to the power integration C1 e to the power integration root bx plus C2 e to the power C1 e to the power root x C1 e to the power minus root x. Okay, sorry. Root sorry me for are you guys there? Following? Hello. So what it would be your CF? CF would be what? C1 e to the power root bx plus C2 e to the power minus root b. This would be your equation. If b is positive, here b greater than 0. But let's say b is negative. Then let's say b would be b equal to negative. B is equals to minus of C. Then we simply put b equal to minus of C. Then your m would be what? Plus minus I root c. Right? In that case, your CF would be what? C1 cos root cx plus C2 sin root cx. Okay. So this would be your solution in that case. So here to get that first condition they have given, the curve should be planar curve should be closed. To get a closed curve, you need to have a trigonometric function. Okay. Now see this equation. This equation to have a trigonometric root of trigonometric form, trigonometric functional form, you need to have b is equals to what? B is equals negative, right? B must be negative, b less than 0. Okay. So from there you can simply say that b must be 0. So your answer would be what? Your answer would be this. Okay. This one you have understood? It is bit delicate, okay? A bit conceptual question. Hello, are you guys there? Okay, let me move on. So this one is another question from 2019. This one is simply using transformation. This one you are saying that this is partial differential equation and I have not taught you the partial differential equation concept. But this is not that tough. Okay, this is really easy one. They have just given a function uxt that is equal to e to the power x into vxt. Okay, reduces this transformation. This is just a transformation. That's just like the first sum. That first sum is based on one variable, so that is in ODE, ordinary differential equation, and this has two variables, two independent variables, so it is in partial differential equation. Okay, what you have to do here you what you have to do, you need to just find d2u by dx2, du by dx and du by dt. You have given u is given, so u is given here, and what you need to do, you need to find du dx, du dx by simply chain rule, first differentiation, then second differentiation with respect to x. Be careful, here I am doing with respect to x. U is a function of both x and t. Here u is a function of that is dependent on vxt. P is a function of x and t. Okay. So when you are differentiating with respect to x, first differentiation of e to the power x is simply e to the power x, and the second term will be like that only. Then you leave the first term and differentiate the second term with respect to x. Okay. Then second derivative if you do, you will get simply this. And now you need to differentiate u with respect to t. Du dt you want, du dt this term you want. So for that you need du dt is equals to simply what? E to the power x, because e to the power x doesn't have any time dependence or t dependence. So e to the power x would be simply outside. It is constant. Its derivative will be constant with respect to t. So that is simply zero. So that term will be gone. Here also chain rule is applying. So we'll get simply one term because your v is both dependent on x and t. So differentiation with respect to t, partial differentiation with respect to t will be there. So your first term will be e to the power x into dv by dt, del v by del t. So this is very easy, right? Now you just need to put this. I have named the equations as 1 and 2. Now you just need to put this value of d2u by dx2, du by dx, and du by dt. If you put that and rearrange, you will simply get d2u by dx2, d2v by dx2 minus dv by dt is equals to 9 into e to the power minus x, just like this form. So they have asked you what is the function fx, 9 into function of x. So that function, if you compare with this function, this equation, so you will simply get fx is equals to e to the power minus x. Okay, so your answer would be what? B, e to the power minus x. Okay. Another question is, this is a 2 marks question. Okay, this is from the homogeneous linear differential equation. Okay, of second order. Okay, as you can see that x square is multiplied with the second order differentiation, x is multiplied with the first order differentiation. So this is you can do by Cauchy-Euler form, Cauchy equation, Cauchy form. But for this kind of equation, you need to take x as e to the power t. Then t would be ln x or log x. Okay. So upon transformation, the given equation becomes this. The thumb rule is like that. If you calculate simply in this using this transformation, you can simply calculate what would be your x square into d2y by dx2. You just simply put it and you can calculate. But you can also remind your this thing is, if you x to the power 2 d2x by d2y by dx square, that is nothing but d into d minus 1, where d is, I have simply written d is d minus 1. If it is x cube into dqy by d by 3, sorry, dx3, then that is d into d minus 1 into d minus, like that. And if it is x into dy by dx, that is simply d. Okay, like that you need to solve. Me erase this thing. So by putting d2 x square d2y by dx2 as d into d minus 1 and x dy by dx as d, after giving this transformation, this will happen. Okay. Some steps are there. I did a step jump because this is very straightforward. This rule maybe you have learned in your undergrad or you are learning maybe. So that's why I have step jump. So after putting these things and calculating, you will simply get d square minus 4 into y is equal to 0. Then if you simply calculate the roots of the auxiliary equation, you will get plus minus 2. Then your y will be like that, c1 into e to the power 2t and c2 into e to the power minus 2t. This one you remember, right? The last class we have discussed about auxiliary equations. So here you need those concepts. Here you need to actually, that's why I told you to brush up these things, because these questions are very easy. But these rules you need to remind, and they in the gate exam they will not give you so much complicated function. They will get simple problems, simple function. Just you need to know the techniques. That way you can simply solve this thing. But your e to the power t is what? X. Then e to the power 2t would be what? X square. And e to the power minus 2t would be what? X to the power minus 2. They have given y1x is x square. So this is, let's say this y is a linear combination of y1 and y2. Linear combination, as I am saying, c1 x square plus c2 x to the power minus 2. They have said that y1 is x square. So this x square is this. So then y1 is x square. Then y2 would be what? X to the power minus 2. They want what? Limit x tend to infinity y to x. If you do simply limit x tend to infinity 1 by x square, that would become 0. So your answer is 0. So you will get 2 marks. Okay, this is very easy question. Just a 4-liner question. So are you guys with me? Are you following? Yes. Okay. So this is another question. This one is from interval, simply the largest interval in which the initial value problem. So you can find the trend, like whenever they are giving some initial value problem, they are not, you don't have to solve actually. Here they are asking about the largest interval in which the initial value problem has a unique solution. So you can simply see by the differential equation, if your x is equals to 5, okay, if your x becomes 5, in that case what? This differential equation is like invalid, okay, that term will go to like infinity, put up to infinity. The differential equation does not exist in that case. Okay, if x is equals to 5, the differential equation, dE I am writing, doesn't exist. So 5 is a cutoff point, like that, you can say. Now, if x is equals to 0, what will happen? ln x, okay. ln x, right? ln x is like that. If x is equals to 0, then your ln x would be minus infinity, like that. So, if x is equals to 0 also, the differential equation doesn't exist, right? So, where it is actually existing? So, you can simply draw the x-axis. So, here let's say it is 0. So, actually what point? 5 plus 5. So when it is plus 5, then the differential equation is not existing. So from 0 to 5 it is existing. Okay. At 5 it is not existing. From 5 to infinity is it existing. Okay. And from let's say 5 to infinity it is existing, and left of 0 also it is existing. Minus infinity to 0. But at this point, at 0 and 5 it is not existing. So x, from where you can choose x, minus infinity to 0, union 0 to 5, union 5 to infinity, right? In this region, x is actually this differential equation is existing. But if x is equals to 0 and 5, the differential equation doesn't exist. Okay. So from that region, you can simply say they are asking about unique solution. But if x is 0 or 5, in that case x you don't get a solution. Now this interval contains what? The point 0. So if it contains the point 0, then your differential equation is not existing at 0. So how you can get unique solution? You will never get a solution at 0. So this is not the answer. Minus infinity to infinity, no, this also contains 0 and 5, those these 2 points. At these 2 points your differential equation doesn't exist. So how will get solution? Forget about unique solution, you don't get a solution here. Now 0 to infinity, but 0 to infinity will contain the point what? 5. At 5 your differential equation doesn't exist, so how will get a solution? You don't get a solution, forget about unique solution. So this is not a interval also. Then the only interval it is actually give you it will actually give you some solution, that is 0 to 5, and that is the only left option. So you can simply say that this is the answer. So this we have done by using trial and error. If you have some insight about the solution, then you can simply say also that how you can solve. This is also easy to solve, but we didn't choose that path because this one is very easy, right? So this one you have understood, right? How we did the solution. So this is your answer. D, option D is your answer. Any problem in this question? Okay, so This is for now for today. I will upload some other problems. I will upload the problems as well as the solution. So those solution would be self-explanatory. But as I have started this previous year's question from this topic differential equation, you can simply see the differential equation questions from the previous years and try to solve. I will give you the solutions of differential equation and I will try to cover all the questions from 2021 to 2029 or 10 or 7 maybe. So all the question I will try to solve and give you the solution. But before seeing the solution, you try to solve. You just collect the question and try to solve. If you face any problem, then see the solution. If it is not in the solution, then ask in the group. I will solve. Okay. So this is for now, but what are the topics that I didn't cover here is the content this. This is another thing that is required a sum of the root of the indicial equation. This indicial equation I have not taught you yet. So this is simply a equation, but I will taught you. Then I will teach you this equation. Then I will discuss the problem. Okay. Another thing is that this Laplace equation. Laplace equation is nothing. For let's say u is a function of x and y they have given. The Laplace equation will be double derivative of u with respect to f x plus double derivative of u with respect to y equals to 0. Or for v also vxx plus vyy. This vxx vyy is nothing but d2 by dx2 uxy. That is vuxx. Okay. Similarly for vxx will be like that. We are differentiating two times with respect to x, that is uxx. We are differentiating u with respect to y two times, that is uy. And there the this combined notation nabla square u would be 0. If it follows, if u follows the Laplace equation, then nabla square u would be 0. And if v follows the Laplace equation, then nabla square v would be 0.